Okay, hello again. This is the next video on step maths, and this video will be about the question you see in front of you, which is question 5 from step paper 1, 1995. Excuse me. So as before, feel free to try the question on your own and pause the video while you do that, or come back to it later maybe. And I will now, from now on, be talking about the answer. Okay, so first part of the question gives a formula for a function f, which uses the notation here with brackets n2 here, meaning n choose 2, which can be written as n factorial over 2 factorial times n minus 2 factorial. Let me just maybe bring that up. Just here we'll use this area for notes. So just let's make a brief note that this notation, let's say n choose r, is the same as what's sometimes written n cr, although you may have different positions for your n and r. That depends on which book you're reading. But of course it's this formula here, which you should be familiar with from studying things like statistics, statistics, binomial theorem, binomial expansion, and of course this is n factorial, meaning n times n minus 1 times n minus 2, and so on, down to 1. An important note, which is something that makes this question unusual, maybe, is that they neglected to mention what kind of number n is, and I think that's because they consider it's just too obvious that you must have n being. Sorry, just readjusting something here. You must have n being a positive integer. Otherwise, this notation is not considered acceptable, so to speak. A little bit careful in what I say, because actually, while you might have been taught that the factorial notation only applies to positive integers, that is true in some sense. So, for example, we can have 3 factorial. You may have been told that there's no such thing as 1/2 factorial, and there's no such thing as minus 4.5 factorial. That is true in one sense, but actually there's a more generalized concept, the gamma function, if I remember correctly. So generally, at the level that we're working, this is not allowed and this is not allowed, but of course this is. So n is an element of the, let's say, the natural numbers, yeah. So that's just a small bit of background on the definition of the function. Now the function is written out in full here, and we're first asked to show that the derivative of the function f dash x, the derivative, has this particular form. So I'm going to show a way to do this which I think makes the most sense, which is to use sigma notation. Now what do I mean by sigma notation? I mean writing this list, this sum of many elements, of many terms, starting with nx and ending with -1 to the power n plus 1x to the n over n, writing that in the form of a sigma or sum notation, and then differentiating it. Okay, so I will now show you that process. Okay, so I've just copied here the exact form of the function that was given, and now we'll try to write this with a sigma notation. So what does that mean? So fx is the sum of terms. Let's write a large sigma. And in each term, what do we see? Well, first of all, we see the n choose r term. So perhaps we can write that as nr, and we see that r is varying 1, 2, 3, up to n choose n being 1, so up to n. And we also see a -1 term, which is changing the sign for each term. So the powers of -1. Now we'll come on to the power in a minute, and then also we have a term in x with a power of x, and divided by r. Now what's the power of x? Let's call it r as well, because we see here, for example, n choose 2 corresponds to x squared, so the r in the n choose r is the same as the power here. But this minus 1 is always a bit tricky. If we consider the case r equals 1, so r equals 1 is this term here. We've got n choose 1 times x to the power 1. Here we've got a power, an even power of minus 1 because it's a positive term. So we need to use plus 1 or minus 1. It doesn't actually matter which. So we'll just use r plus 1 here, because that means that when r is 1 we have minus 1 to the power 2, and when r is 2 we have minus 1 to the power 3, which is how it should be. Now also when you do a sigma, a sum, you need to write the beginning and end to make it clear. So here we're varying from r equals 1 to n because the first power of x is 1 and the last power of x is n. So that is a correct expression for f of x. And of course the value of that is that when you want to differentiate, well, the value of that in this question is that when you want to differentiate the function, it suddenly becomes very easy, because differentiation of a sum, remember, is the sum of the derivatives. Yeah? The derivative of a sum is the sum of the derivatives. That sort of linguistic pattern reflects the fact that a sum and a derivative operation are interchangeable on a sum. Let me just make a note of what I mean there, because it might sound like total gobbledygook if you're not used to this. What I'm saying is that d by dx of the sum of functions of x is the same as the sum of d by dx of each function. And this is a basic fact about differentiation that you would have learned very early in your study of calculus. So of course that means that when I differentiate this expression, I can simply basically ignore the sigma and just differentiate the general term. So how do I do that? Sum. So r is still running from 1 to n because I'm differentiating every term in the series. The nr will not change because it's a constant multiple of this function of x, isn't it? The minus 1 to the r plus 1 will also not change. But here's where it gets a bit tricky. Now, x to the r will change to rx to the r minus 1. So I'm going to get x to the r minus 1. And now let's just carefully examine what we've got here. We've got a term, our first term, r equals 1, had x to the power 1. So that has changed to x to the power 0, giving a constant term. Okay, so this seems to be a correct formula. Now this is no good to us as an answer, because if you remember what we were being asked, as is shown here, is to show something, to show that derivative takes this form. Now this form of course is not a sum at all. So the first step that I've taken, simply differentiating each term in the sequence, is very obvious and very basic. But it doesn't answer the question. Somehow we're supposed to make this into a sum. Now, to me, I suppose the big clue when I did it was that I noticed immediately about this expression is that it looks very much like something I've seen before. And what that is called the binomial, I'm never sure, binomial theorem or binomial expansion. Anyway, the binomial thing, which tells me how to write out the complete sum relating to an expression of the form a plus b to the n. So let's remind ourselves that a couple of basic formulas that are really given great importance in A-level maths, which the first one is the general form of a sum the power of a sum of two terms a and b. If the power n is a natural number, which we assume it is in this question, as I said, because they're using n choose r notation, which only works with positive integer values of n, then we have this kind of pattern: a to the n plus n choose 1, a to the n minus 1b plus n choose 2, a to the n minus 2b squared, and so on, the pattern continuing up to b to the n at the end. And you also would have learned the special case, or at least you would have looked at the special case, let's say 1 plus x. So where one of these terms is 1, this obviously simplifies down a bit to 1 plus n times x plus n choose 2, which is n minus 1 over 2 x squared, plus and so on up to finally x to the n. Now if we compare especially that second that is an identity, of course. If we compare that second expansion or series with the one that we're given, we see that there's some similarities but some slight differences. The first difference is that the 1 is not here. Yeah, there's no 1 at the start of the series, so that makes it look a bit strange to start with. But okay, it's different by 1. But the other big difference, of course, is these minus signs here and so on, alternating minus signs. And then we think, well, okay, that's not such a big problem actually. If I want to make this fx look very similar to 1 plus x to the n, well, all I have to do is just change the sign of x, right? Because 1, let's use black here, 1 minus x to the n is the same as 1 plus minus x to the power n, which means that I can replace x with minus x, giving me 1 minus nx plus n choose 2 x squared minus n choose 3 x cubed, and so on with alternating signs. And now I have something that looks extremely similar to this. The only thing remaining that's still different is this dividing by 2, dividing by 3, and dividing by r up to n. So it is still a bit different, but that must give us a big clue, because after all, if I do have a series that looks like this, then I can replace it with this series. Now none of that is conclusive or definitive. It's just a big clue, and it's the kind of clue you have to be able to recognize in STEP, as I've said already in some other videos. The business of recognizing a pattern where it isn't told to you, but you should just try and see it for yourself. Okay, I'm going to remove all that so we can continue normally. What's going on? So we have the derivative f dash x, but we want, the final answer that we want is of the form f dash x equals, I think it was 1 minus x to the n over x. And we say to ourselves, okay, this is what I know to be true here, and this is what I want. How can I go from one to the other? So we try and use this clue of the similarity to a binomial. Okay, well the first thing I notice is that the final expression is divided by x. And I also notice that the power of x here is kind of wrong. Because we've differentiated, we've brought the power down by 1. So that's why this doesn't actually look like a binomial expansion. So both those things together help you to see that the first thing to do is simply multiply the expression you've got by x. So in other words, take this x up to the left hand side, multiply it by that, and see if we can get 1 minus x to the n. Then we'll be finished, you see. Let me just erase all this stuff. So that's what I'll do. All I'll do is multiply my expression by x. So therefore x times f dash of x, or derivative of x, and this x multiplies into every term in the series. N choose r, still, minus 1 to the r plus 1, still, and then x to the r, and from r equals 1 to n. Now let's think about that. Is that the same as 1 minus x to the n? 1 minus x to the n is the sum of n choose r, 1 to the, let's say, r, and minus x to the n minus r from r equals 0 to n. Very important to know that the binomial expansion goes from 0 up to n, so it always has n plus 1 terms, not n. So the kind of key difference here, of course, the 1 to the power r is always 1, so you don't have to include that. So the only real difference here, you see we can take the minus 1 power of minus 1, it will basically look like this. The only main difference is this 0. It starts from 0, not 1. Now the term when r equals 0 is just 1. So I can rewrite my expression on the left-hand side there as a sum going from 0 to n and then correct for this missing 1. So this is the same as, let's do it carefully, the sum from r equals 0 to n. The same thing here, n choose r. Sorry, that bracket looks wrong, doesn't it? N choose r minus 1 to the r plus 1. That won't change there. X to the r. But now I'll have to subtract something. What do I have to subtract? I have to subtract the term that I get here when r is 0. When r is 0, then I get n choose 0, which is 1, minus 1 to the plus 1, which is minus 1, times x to the 0, which is 1. So it's minus 1, isn't it? I think that's right. Because the term you get, yeah. Okay, now we have to acknowledge the fact that the power of minus 1 is wrong here. If we look at I mean, when you get confused about what the terms in the series look like, I recommend you just write it out in rough. Let me write out this series in rough. I'm getting n choose 0, so I'm getting minus 1. The second term is n. Now hold on, let me get this right. The second term I've got, yeah, nx, right? And the third term I've got n choose 2. What am I doing here? R is 2, so sorry, it's minus n choose 2, and so on and so on. Minus n choose 2 x to the power of 2, and so on. So it's nx minus n choose 2 x squared, and so on and so on. So plus n choose 3 x cubed, and the sign alternates, and so on. And the last term would be the last term would depend. The sign of the last term will depend on whether n is odd or even, right? But basically the sign alternates up to x to the n. So what I have here, is that the same as 1 minus x to the n? Well, no, it's not quite, is it? That's equal to minus 1 minus nx plus n choose 2x squared minus dot dot dot, which is minus 1 minus x to the power n. Okay, so having verified and sort of double checked that it is what we think it is, we're getting that the series term is minus 1 minus x to the n, according to the binomial expansion or binomial theorem. That's actually so minus 1 minus x to the n minus minus 1, so that's plus 1. So finally we're getting the result we want. X f dash x equals 1 minus x to the n, and here I'll put QED because that is what we were to show, which is that the derivative f dash x, let's verify, is 1 minus x to the n divided by x. Okay. Excuse me. So now we'll move on to the second part. The second part says deduce that the function fx is equal to the integral from 1 minus x to 1 of the function 1 minus y to the power n divided by 1 minus y dy. And I think this part of the question is going to confuse, or at least is going to be rather difficult for many students. And I think what makes it difficult is this change of variable from y to x. That is really going to throw people a lot. So you can get mixed up here easily. If, for example, if you get involved with the chain rule, you might find that it's not working quite how you want it to. If you use the chain rule, you have to do so carefully. Let me just say that. But I think let's not worry too much about the chain rule. Let's just make sure we understand the integration aspect of this. Sorry, I had a slight mistake there. I was just saying I'll try my best to explain it. we're going to write the formula that we've just been given. The formula was f derivative is 1 minus x to the power of n divided by x. Now let's remember what's called the fundamental theorem of calculus. I'll just write ft of c. I hope you understand. The fundamental theorem of calculus. What is that? It's basically saying that integration and differentiation are opposite processes. But one of the most useful ways to remember it is as this particular formula, which is to say that the integral of the derivative of a function, so the idea that these two processes are opposite, if it's a definite integral from value a to value b, will always be that function evaluated at b minus that function evaluated at a. I really do believe it's worth remembering it in that specific form, because there are many questions where you can use that formula to deduce something interesting. So assuming you know that, you can apply that idea to this question, can't you? Because the question is asking, if we go back to the question, the question is asking us to give a different expression for fx, and we're to deduce it, which means we're to use the idea, use the formula that we've just calculated or derived. We just derived this formula for the derivative. So let's simply integrate the derivative and apply the fundamental theorem of calculus. And that will get us most of the way to the answer. So if I integrate now from a to b, actually in the question it's given that the limits you want are 1 minus x to 1, and here I'll put the derivative 1 minus x to the power of n divided by x dx must be equal to the function value evaluated at 1, the function value at 1, minus the function value at 1 minus x. Okay, I just stopped the video there for a moment because I realized that I made a, let me call it a classic mistake, a very, very common mistake amongst students, and as it turns out amongst me too. So what is the mistake here? Can you see what I've done wrong? What is it about that line which is, let's say, completely wrong? Okay, the answer is that you cannot do what I've done on the left-hand side. What I've done on the left-hand side is use the variable x in the limit on the integral, but the integral is an integral over x. Yeah? So x is the variable inside the integral. You can't use it as part of the limits. Imagine it like, oops, sorry, what was that? Imagine it like a graph, and you're integrating between limits a and b. Well, you can't have the value of a be a function of x because this is the x-axis. So absolutely you can't do that. So let's be the good thing to do with this kind of tricky question where you having to carefully interpret the meaning of each bit is just do it very, very slowly. In other words, in each step don't jump too much. So here, for example, I started with the fundamental theorem of calculus, so let me not jump too much. I've put in the value for f dash x, but let's just leave the limits as a and b so that we don't confuse ourselves too much, as I obviously did just there. So here we need to do a and b, let's say, and that means, of course, that on the right-hand side we've got fb minus fa as before. Right. Now, the next step is fairly obvious because of the form that the question is the form of the answer is given in the question. Here, 1 minus y to the n divided by 1 minus y. Our integral must look like that. So in order to make that happen, we can easily see that we just need to use y is equal to 1 minus x. So what we're doing is substituting. We're doing, as it were, integration by substitution, or we're changing the variable of the integral, you could say. So we make the substitution, y is 1 minus x, and we get the following. Integral from a to b, 1 minus y to the power n over 1 minus y as required. Now dx, be careful, because dy by dx is not 1, it's minus 1, isn't it? So this is actually minus dy, and then we've still got fb minus fa. And now we look at the question and we see the form that we're looking for is the form is one with limits between 1 minus x and 1. Oh, sorry, I made another silly mistake, didn't I? Can you see my second silly mistake? Yes, if I make a substitution, I must also change the limits. If y is 1 minus x, then this is 1 minus b, and this is 1 minus a. Changing the limits in accordance with that substitution. Now, if I want those limits to be 1 and 1 minus x, it follows that a must be x, and b must be 0. This gives us integral from 1 minus x to 1 of 1 minus y to the n over 1 minus y dy equals, now be careful, we had a minus sign here, so let's just flip this, fa minus fb, fa being fx and fb being f0, and finally we can observe that f0 is simply 0. If you look at the function, if you put 0 in for x, all the terms are 0, so this is fx. And that is QED because that was to be shown, that fx is equal to this specific integral. Okay, so that's the second part. Okay, the third part of the question comes under the heading very easy if you know how. I'm amazed at the number of students that I found were not able at first sight to solve this problem, which is basically what is the value of, integrate this function, basically. The function is 1 minus y to the n divided by 1 minus y. How do we integrate this? Well, of course, one approach of integration that you've learned is when you have rational functions, like, for example, I don't know, 3x plus 2 over x plus 7, x plus 5 or something, is to use the method sometimes called partial fractions, to split this into separate fractions which can then be integrated. But in this case, there's no need for anything so complicated. Let me just show the third part of the question again. So it's hence, very important word to show that f1 is the following. So hence means we're going to use this specific integral. We're going to substitute x equals 1 into this integral. That will give us from 1 to 0. Yeah, and we're going to have to integrate this integral. Now it's actually very easy. The answer is that the two functions, 1 minus y to the n and 1 minus y, have a common factor. What is that common factor? Obviously, it's the linear factor 1 minus y. And it's something that you should know, but you might forget, is that actually we can always write 1 minus y to the n as 1 minus y, and then a simple geometric sequence like that. Another way to remember it is from knowledge of geometric sequences or geometric progressions, which is that 1 plus r plus r squared plus ... is equal to 1 minus r to the n over 1 minus r. Yeah. So if you think of that as an algebraic expression, it's saying 1 minus x to the n is 1 minus r times 1 plus r squared plus r cubed up to r to the n minus 1. Here n terms, and so you get the nth power there. So that knowledge should be well within your grasp, but it's very common for people just not to notice that they can solve the integral in that way, because obviously that means that the ratio 1 minus y to the n over 1 minus y is just the geometric sequence itself. So we've got 1 plus y squared up to y to the n minus 1 dy, which obviously is just f1, of course, which means x equals 1, which means integral from 1 to 0. And of course that gives us the easy integral y plus y squared plus y to the power n, divided by, of course, divided by 2 divided by n, with limits from 1 to 0, which gives us, as required, 1 plus 1 over 2 plus 1 over 3 plus 1 over n. And again, that was to be shown. So that last part, actually very easy, as long as you know how. Okay, what can I say about this question? It's a very interesting one, I think. I think this question should be evaluated as sort of medium difficulty. Maybe some students will actually find it very hard. And I think it depends on how familiar you are with some of the ideas, of course. The most important thing is to be very familiar with the binomial theorem. If you don't immediately think binomial when you see that function at the beginning, then you perhaps don't have enough knowledge of that area of mathematics. And indeed, if you don't think about binomial at all, then I guess you won't be able to solve the first part of the question. Sigma notation helps a lot because it keeps the process very compact. Do make use of sigma notation to help you, because writing out long streams of terms can be really annoying in this kind of question. The second thing is the jump from this to this, as I said during the video, is something that most students find very confusing, because this substitution, or this change of variable from 1 minus x to y, dealing with that correctly in terms of the integral is something that throws people off, and me included. I found it quite confusing. But I refer you back to what I said about this, which is base what you're doing on the fundamental theorem of calculus. This formula is maybe not emphasized enough in the British curriculum. It's very heavily emphasized in the American curriculum, actually. But it's the basis of a lot of very good work that you can do. So base it on that, and just step by step work towards the form that they're asking you to find. And of course, the last part, as I said, is very, very easy if you know how, which is just simply write this fraction as a sum there, and then the answer is just trivial. So yeah, interesting question. I hope you found that useful, and speak to you again soon.